In Module 4, Lesson 28, we're going to continue our work with solving systems. And if you remember, we actually have three ways to solve systems. And the one we spent a majority of our time on, I'm talking here about solving a linear system. The one we spent a majority of our time on is graphing, okay? If I can spell it correctly. So the two we're going to focus on today are substitution, which I touched on before, but I'll give you a couple more examples of that, and what's called elimination. Or sometimes, if you're old like me, linear combination. Okay, linear combination. So we're going to start with number 3 here. These are three ways of solving a system. Remember, a system is two or more equations representing the same real life data or same problem or same unknowns. And when we find a solution, we're looking for the x and the y value that make, if there's two equations, both equation true statements. If there's three equations, make all three equations true statements. So let's get started with elimination. Use what you've noticed about adding equivalent expressions to solve the system by elimination. Here's our key right here. You're going to add the two equations together to make something be eliminated. By that something, I would mean either the x or the y. So when we look at these two, if I, maybe go keep, change, change, or subtracting is the same thing as adding the opposite, I have 6x's and 2x's below it. I have negative 5y's and a positive 5y's. Notice that these are opposites, and that's the key to elimination, is you need to have opposites so they get eliminated when we add them. Okay, so basically if I add these together, if I have 6x's plus 2x's, that's 8x's. Negative 5y's plus 5y's cancels out, equals 21 plus a negative 5 or 21 minus 5, which is 16. And remember, this is 8 times x. We undo that by dividing by 8. 8 divided by 8 is 1x. 16 divided by 8 is 2. Awesome. We have our x value. But remember what I said a while ago, that a solution, that's what we're trying to find here, we're solving, is an x and a y value that make both equations true. Once you find the x, though, we can find the y by plugging it into either equation. You don't have to do both. You can just do one or the other. I'm going to do both to show you. But here's why it doesn't matter, okay? So let's say I take the first equation here, and I take 6x plus a negative 5y, or you could say minus 5y, equals 21. Okay, and I know x is 2, so I'm going to plug that in here for x. So I'm going to go 6 times 2 plus negative 5y equals 21. 6 times 2 is 12. So basically what I'm doing now, guys, is I am just solving equation, okay? Simplifying and solving. So I'm solving for I'm solving for y. So I'm going to solve for the negative 5y, which means I got to get rid of this 12 over here. It's a positive 12, so I'm going to combine it by a negative 12. Whatever I do to one side of the equal sign, I got to do to the other. That gives me 0. I'm left with negative 5y equals 21 minus 12 or plus a negative 12, which is 9. Now this is multiplying, so I can do that by dividing. And so I'm going to divide both sides by a negative 5. And I'm going to get y equals, you can just write it as a negative 9/5, or I think that's negative 1.8, if I divide that correctly. Okay, either one works. We're done at that point. Okay, but I want to show you that it works for either equation. So it doesn't matter which one you pick. So if I take 2x plus 5y equals negative 5, and again, I'm going to plug a 2 in here for x. This is going to be 2 times 2. Look at me get ahead of myself because we know what 2 times 2 is. Guess I could skip that step, huh? Plus 5y equals negative 5. 2 times 2 is 4. 4 plus 5y equals negative 5. Now again, we're solving for our unknown, which is y. So I'm going to solve for 5y. Got to get rid of the 4. It's a positive 4. I combine it with a negative 4. Whatever I do to one side, I do to the other. That gives me 0, and I'm left with 5y equals negative 5 plus negative 4 is a negative 9, because you think of the number line, right? You go down 5, you go down 4 more, you're at negative 9, and you divide both sides by 5, and look what we get. We get y equals negative 9/5, or again, if you divide that out, it's a negative 1.8. So basically, ladies and gentlemen, you don't have to do both. Okay, you just pick one of the equations, substitute it in, and get your unknown value. Another way we write the solution instead of, writing it like this is we can write it as an ordered pair. Think of the graph, our solution's an ordered pair, right? So we can have 2 and negative 1.8. This is our x value, this is our y value. Okay. So that's elimination, and it's really handy when you have something that divides out like this. But what happens, and I'm going to move on here, so if you need to pause or anything to write this down, go for it. But what happens when it says solve using elimination, and if I look here and make it subtraction, the x terms or the y terms don't cancel out. Well, now we have to, oops, play with our mouse some more. Now you have to make opposites. Okay, so you need opposites. We can make opposites using some of the properties we know. So if I look at these two, I can look right here and I say, you know what, negative 2, if that was a negative 4, that would be opposite 4x. So what if I took this whole thing right here and I multiplied it by 2? The whole thing. Because remember, we can do whatever we want as long as we do it to both sides of the equal sign. So I can take this side and multiply it by 2. 2 times a negative 2 is going to be a negative 4x, plus 2 times 7y is going to be 14y, and that's going to equal 2 times 5, which is 10. Again, I multiplied the left side, like the distributive property, and then multiplied the right side. Why did I multiply by 2? Because now if I just write down my second equation, I have created opposites. For elimination or linear combination, you need opposites. So I didn't change this problem. Remember, we've done that, right? If you've they have the same ratios, or if you multiply everything by the same number, it's going to be an equivalent equation. Now we just add them. Notice that these two give me 0. Yay. Eliminated. 14y's plus a negative 2y's is going to be 12y's. 10 plus 14 is 24. This is 12 times y. I undo that by dividing by 12. Whatever I do to one side, I do to the other. And I'm left with y equals 2. Awesome. But remember, we need to know what x is. So you can pick this equation. Heck, you can even pick your new equation if you want. But just pick one. And I'm just going to take 4x right here. Okay, and I'm going to say, hey, y is 2. So I'm going to plug a 2 right in right here. And I'm going to say 4 times x plus negative 2 times 2, just plug 2 in there, for y equals 14. And now I'm going to simplify and solve. Negative 2 times 2 is negative 4. Now I'm solving for x. I'm going to solve for 4x. I have to get rid of the negative 4, so I combine that with a positive 4. Whatever I do to one side, you do to the other. You're left with 4x, that gives you 0, equals 18. And then this is multiplying, so I undo that by dividing. And you're left with x equals, if you reduce it, 9 over 2, like if you divide both of them by 2, or 2.25. Okay? I don't have to check the other one. I know it's going to be a solution. Okay? Again, if you wanted to, you could write your solution like this. Nope. X term comes first. 2.25, that's my x, and then 2 is my y. You don't need the x or y up top. All right, so that is elimination. And real quick, I want to just do one more problem in this video with you. This is on substitution. So remember, we have graphing, substitution, elimination. We've just done 2 with that elimination. Now, if you look at this one, it says solve using substitution. You substitute things in. We just did it in this last problem. I knew that y equals 2, so I substituted 2 in for y. Okay? So think of the same thing here. I know that y equals negative 4x minus 7, and I know that y equals 5x plus 2. So I can take, let's say, this top one here, and I can substitute it in for y. Or you could have went the other way, because it doesn't matter. So instead of saying y, well, y equals negative 4x minus 7, so I'm going to write it as plus a negative 7. That equals 5x plus 2. Okay? So you just substitute. If you know what one of the variables are, you can substitute it in for that variable in the second equation. Okay? Now, back to solving equations. Simplified, simplified. We have variables on both sides, so we just get rid of them on one of the sides. I'm going to add 4x to both sides because I like dealing with positive numbers. Okay, so this is why we spent all that time solving equations before. That cancels out. I have negative 7 equals 5x's plus 4x's is 9x's plus 2. Solving for x, I'm going to solve for 9x. That means I have to get rid of the 2 because it's on the same side of the equal sign. It's plus 2, so I'm going to go minus 2. Whatever I do to one side, I do to the other. Notice a theme here, right? Negative 7 plus negative 2 is negative 9. Bring down your 9x. Double check to make sure those are 0. Again, still solving for our unknown x. So this is 9 times x, so I'm going to do the inverse. I'm going to divide. And I'm left with x, 1x, equals negative 9 divided by 9, which is a negative 1. All right, so we know our x value. Now we got to know our y value, and you can use either one, okay? I'm just going to use the second one here. Either equation works. X is negative 1, so I'm going to plug that in there. I'm going to substitute it in for x, and I'm going to get y equals 5 times negative 1 plus 2. That's negative 5 plus 2. That's negative 3. Okay, so you can write it like this, or you can write it as an ordered pair. All right, so graphing, we spent a lot of time on graphing. Our focus today, not that we're not doing graphing, is on the other two methods. Using elimination by working with opposites, or if you know what one of the variables are, substitution's a pretty convenient way to solve.